Good morning everyone. Today we are going to start with a new chapter of chemistry, lesson 3, metals and non-metals. Now as we all know that there are a number of elements, around about 115 elements known to us till now. And these elements, they are divided into two main groups, that is metals and non-metals on the basis of their properties. Alright, so we can group them as metals and we can group them as non-metals. So today first we will study about the physical properties, right? Mainly what we see first of all, when we look at any element, we come to know about its physical properties, how it looks, right? Whether it is hard or it is soft. So there are so many properties that we'll see today. So today we'll learn about all the physical properties. And then after that we'll learn about the chemical properties of metals and non-metals. That is, how do they react? Chemical properties means their reaction with air, that is oxygen, their reaction with water, their reaction with the acids, their reaction with the other salt, how do they react? That is the chemical property, right? So today we will learn only about the physical properties. So these physical properties you have been doing in your previous classes also. You have learnt about that. So we will have a quick revision of what you have already learnt. You have learnt about metals, non-metals in class 9, class 8, class 7. So today we will just learn this, and we will also learn about some of the exceptional cases. Right? So first property, if we see of the metals, they are generally hard. If we see the metals like iron is so hard, right? So or the other metals like aluminium, magnesium, all these, they are hard, but there are two exceptions. You have to learn these exceptions very nicely. You should know the exceptional cases. So except sodium and potassium, which are soft. They are so soft that you can easily cut them with a knife. Right? So these two are the exceptional cases. On the other hand, non-metals, they are generally soft. But if we see diamond, which is an allotrope of carbon, carbon is a non-metal. And there are two allotropes of carbon, diamond and graphite. So if you see diamond is the hardest substance known. So that is very hard. Secondly, metals, they are solid at room temperature. Except mercury, which is a liquid metal. Right? Mercury you must have seen in the thermometers also. The silver. At the tip of the thermometer, there is a silver point. In that mercury is filled. Right? So mercury is a liquid at room temperature, while all other metals are solid. Non-metals may be solid, liquid or gas. They can occur in all three forms, like carbon, sulfur, phosphorus. They are solid. Bromine is a liquid non-metal, while all the gases like oxygen, nitrogen, hydrogen, then chlorine, these occur in the gaseous form. Then third point, they are malleable. Malleable means the property by which they can be beaten into sheets. Right? They can be beaten into sheets like silver and gold. They are the most malleable substances. Then comes aluminium, copper, aluminium foil. You must have seen aluminium foil in which you wrap your food, right? So that can be beaten into very thin sheet, very thin foil can be made out of it. Copper sheets, right? So these are the silver and gold, because they can also be beaten up into sheets, right? Silver foil, which is used on the sweets. मिठाई के ऊपर आपने देखा होगा जो चांदी का वर्क लगा होता है, ऐसे सोने का वर्क भी बन सकता है. So they can be beaten into very thin sheets. While non-metals, they are non-malleable, you cannot beat them. Then they are ductile. Ductile means they can be drawn into wires, into long wires. You know, this iron, although it is very hard, but when it is hot, when it is extracted also, it is very soft, and you can draw the wires, iron wires, which are used to make even the gauge, iron gauge, right? Then copper wires, which are used in the household for electric currents, for passing the electric currents also. Then silver and gold, they are the most ductile metals. You know, just 1 gram excuse me, just from 1 gram of gold, 2 meters long wire can be drawn. That is why, because they are malleable, silver and gold, they are ductile, they are used to make ornaments. They can be hammered, so they can be beaten into sheets, they can be beaten into wires, earrings, right? They are made of wires, very thin wires, or other ornaments which are made. That is because of their property of malleability and ductility. While non-metals, they are non-malleable, non-ductile, but they are brittle. This is the property of non-metals, like sulfur and phosphorus. Brittle means when they are hammered, they break into pieces, right? So that is brittleness. Next, fifth property is metals are good conductors of heat, like silver, that is the best conductor of heat. Then copper, aluminium, all these metals, they are good conductors of heat, that is they allow the electric current to pass through them, right? But here the exception is lead. Lead is the poorest conductor of heat in case of metals. Non-metals, they are poor conductors of heat. Then metals, they are good conductors of electricity, like silver, copper. They are very good conductors of electricity. Then aluminium, gold, etc. They are good conductors. While mercury and iron, their conductivity is low. Now, you must have seen copper, although silver is the best conductor of electricity, but because it is very expensive, we cannot use silver wires. But mostly what is used? Copper is used for electric wires, for conduction of electricity in the household also, in all the buildings, etc. Copper wires are used for the purpose of passing electric current. Then here, the non-metals, they are poor conductors of electricity, except another allotrope of carbon, that is graphite. Graphite is a good conductor of electricity. That is why graphite electrodes are used in the battery also. Then metals are lustrous. Now, if we have to show this through experiment, that is good conductor of heat, it is a good conductor of heat, what we can do is, I'll write this. We take a clamp stand, right? We take a stand takes a rod. We can take an aluminium rod, copper rod, any rod, and here at the end we put some wax. We stick some wax here, and with the wax we put some oil pins. You can put some oil pins here. Right? Now what we do is we place a burner here. Right? We place a burner here and start heating it. Now what will happen? This rod, it will start getting heated up here. But we will see that suppose this is a copper wire or anything, this will not melt. It will get heated up. And although we are burning, we have put the fire here, we are providing it heat at this place. But that heat, it will pass from here to here, and this wax will start melting. And slowly what will happen? First, this nail will drop down, then the heat will pass on, then this nail, then this, then this. That shows that this metal wire or the metal rod that we have put, this is a good conductor of heat. It is passing the heat here, and that is why the wax starts melting. Although we are supplying heat at one end, it reaches till the other end. That shows metals are good conductors of heat. You must have seen also when suppose you are making any vegetable or you are making tea or anything, and if you put a spoon on the side of the pan, and after sometimes that becomes very hot, that spoon becomes the handle of that spoon, it becomes hot. Why? Because the heat has been conducted from one end to the other end. So metals are good conductors of heat. Same way, if we take a battery, right, and to that battery we attach a bulb, and on the other end we place when we take the wire, then to that wire suppose we attach a safety pin or anything on the clip, and then the other end to the bulb. Right? When we will switch on the battery, what will happen? That bulb will start glowing. That means that safety pin, because it is made up of a metal, that has conducted the electric current. But in place of that safety pin, if in between the clips we add a rubber band, then what will happen? The bulb will not glow, because a rubber band or an eraser you can put, that is a non-metal, that will not conduct the electricity. Right? Then metals are lustrous. Lustrous means they have a shiny surface. They are not dull, they are shiny. While non-metals, they are not lustrous. They are dull. Right? But there's an exception, that is iodine. The iodine crystals, they have a shining surface. So all these exceptions you have to learn. Then metals have high melting points and boiling points, except sodium and potassium. They have of course low melting point and boiling point, or if you talk about melting point. And gallium and cesium, these two metals have very low melting point. Their melting point is hardly 30 degree and 28 degrees Celsius respectively, and the melting point is so low that even if you put them on your hand, just by the heat of your body temperature, the heat of your hand, the metal will start melting. So gallium and cesium, they have very low melting point, and sodium and potassium too have low melting point. Then comparatively to metals, non-metals also have low melting point and boiling point, but there is one exception, that is diamond. Diamond have high melting point and boiling point. Then they have metals, they have high density, right? That is, they are heavy. High density means they are heavy, except sodium and potassium. But the non-metals, they have low densities. They are very light, because mostly they are, if even they are in the solid form, they are mostly in the powder form. They are brittle. They can break down very easily. So they are having low densities. Then metals, they are sonorous. Sonorous means they produce sound when they are hit. That is why in the temples, etc., you must have seen the bells. They are made up of brass. You know, when they are hit, they make sound. Then non-metals, they are non-sonorous. They do not produce any sound when they are hit. So these are the main differences in the properties of metals and non-metals. So and of course each of these, mostly they have some exceptional cases. Learn these properties nicely, and then next time we will take up the chemical properties. How do these metals or non-metals, they react with different substances? What is their reaction with oxygen or water or acids, etc.? That will take up in the next term, right? So till then, keep safe. Thank you.